Welcome to our journey through the cosmos. Fasten your seatbelts, because we're about to embark on an exhilarating exploration of the universe, a grand cosmic stage where stars are born, galaxies collide, and even the impossible seems attainable. Today, we'll uncover some mind-blowing facts about the universe and explore how our beautiful Earth and life itself came to be. From the explosive birth of the universe to the intricate dance of molecules that gave rise to life. We'll traverse billions of years in just a few minutes. Get ready to have your mind blown wide open.
Our story begins roughly 13.8 billion years ago, in a state of unimaginable density and heat, where the entire universe was compressed into a singular point. Imagine a universe smaller than an atom, containing all the matter and energy that would eventually become everything we know and love, from the tiniest particles to the vast galaxies. This wasn't just an explosion in space, but space itself, an expansion so rapid and profound that it continues to this day, shaping the cosmos as we see it. We call this event the Big Bang, and it's the prevailing cosmological model for the universe's origin, explaining the initial conditions and subsequent development of the universe. In those first fleeting fractions of a second, the universe underwent a period of exponential expansion, inflating faster than the speed of light, a phenomenon that defies our everyday understanding of physics. This period, known as inflation, smoothed out the fabric of space-time, erasing any irregularities and setting the stage for the universe we observe today. As the universe expanded and cooled, energy began to condense into matter, following Einstein's famous equation E equals mc squared, which describes how energy can be converted into mass. First came fundamental particles like quarks and leptons, the building blocks of all matter, emerging from the energy-rich environment of the early universe. These particles, once swirling in a chaotic soup, began to coalesce, forming protons and neutrons, the very heart of atoms, which are the fundamental units of matter. The early universe was a hot, opaque plasma, a cosmic fog that trapped light within its dense embrace, preventing it from traveling freely. But as the universe continued to expand and cool, something incredible happened, setting the stage for the formation of the first atoms. Around 380,000 years after the Big Bang, the universe had cooled enough for electrons to be captured by protons, forming the first atoms, predominantly hydrogen and helium, the simplest and most abundant elements in the universe. This event, known as recombination, marked a pivotal moment in cosmic history, allowing the universe to transition from an opaque plasma to a transparent state. The universe, once opaque, became transparent, releasing the first light that had been trapped since the Big Bang, a momentous event that allowed light to travel freely through space. This ancient light, stretched and cooled over billions of years, is what we observe today as the cosmic microwave background radiation, a faint echo of the universe's fiery birth, providing us with a glimpse into the early universe.
The early universe, while teeming with the raw materials for stars and galaxies, was surprisingly uniform, a vast expanse of nearly identical conditions. Gravity, however, had other plans, setting the stage for a cosmic drama. Over millions of years, tiny quantum fluctuations in the density of the early universe, amplified by gravity, began to draw matter together, creating the first seeds of structure. These clumps of matter, denser than their surroundings, acted as seeds for larger structures, the precursors to galaxies. Gas clouds, primarily composed of hydrogen and helium, collapsed under their own gravity, spinning faster and faster as they contracted, forming the first stars. The immense pressure at the center of these collapsing clouds ignited nuclear fusion, the powerful engine that powers stars and lights up the universe. And so the first stars blazed into existence, colossal furnaces forging heavier elements in their cores, elements that would be crucial for future generations of stars and planets. These stellar pioneers, far more massive and short-lived than our own sun, illuminated the early universe with their intense radiation, driving back the cosmic fog and shaping the distribution of matter, creating the first hints of structure. As stars lived and died, some explosively as supernovae, they seeded the surrounding space with heavier elements like carbon, oxygen, and iron, essential for the formation of planets and life. These elements, forged in the hearts of stars, would become the building blocks of planets, and ultimately life itself, setting the stage for the complex chemistry of the universe. Over eons, gravity continued to sculpt the universe, drawing stars together to form vast swirling collections known as galaxies, each a cosmic city of stars. Our own Milky Way, a barred spiral galaxy, is just one of trillions estimated to exist in the observable universe, each with its own unique story and history.
Chapter 3. A Star is Born, the Formation of the Solar System and Earth. This chapter delves into the fascinating process that led to the creation of our solar system and the planet we call home. Within the Milky Way, about 5 billion years ago, a relatively unremarkable event occurred: the birth of our Sun. This event, though seemingly ordinary in the grand scale of the universe, set the stage for the formation of our entire solar system. A giant molecular cloud, enriched with the remnants of past stellar generations, began to collapse under its own gravity. This collapse was the beginning of a complex and beautiful process that would eventually lead to the formation of our Sun and the planets orbiting it. At the heart of this swirling cloud, a protostar ignited, our Sun in its infancy. This young star began to shine, marking the birth of a new solar system. As the young Sun gathered mass and radiated energy, the surrounding disk of gas and dust began to cool and coalesce. This disk, known as the Solar Nebula, was the birthplace of the planets. Dust grains, remnants of long-dead stars, clumped together, forming larger and larger aggregates. These tiny particles, through countless collisions and mergers, began to form the building blocks of planets. This process, known as accretion, is the fundamental mechanism by which planets form. Over millions of years, these small clumps grew into planetesimals and eventually into full-fledged planets. In the inner region of the protoplanetary disk, where temperatures were scorching, only rocky materials like iron and silicates could condense. This region was too hot for volatile compounds to remain solid. These materials gradually accreted, forming the inner terrestrial planets: Mercury, Venus, Earth, and Mars. These rocky worlds would become the closest neighbors to our Sun. Further out, beyond the frost line where temperatures were frigid, ices like water, methane, and ammonia could also condense. This region allowed for the formation of different types of planetary bodies. These icy bodies, along with rock and metal, formed the cores of the gas giants: Jupiter, Saturn, Uranus, and Neptune. These massive planets would dominate the outer regions of our solar system. These behemoths, with their immense gravity, sculpted the outer solar system, flinging icy debris into the distant reaches, forming the Kuiper Belt and Oort cloud. These regions are filled with countless icy bodies and comets. Earth, our pale blue dot, formed in the habitable zone, a region around the Sun where temperatures were just right for liquid water to exist on the surface. This delicate balance of conditions made Earth uniquely suited for life. This seemingly simple fact would have profound implications for the emergence of life. The presence of liquid water on Earth created the perfect environment for life to begin and evolve, leading to the diverse and complex biosphere we see today.
Chapter 4: A Hostile Cradle, Early Conditions on Earth. The early Earth was a far cry from the hospitable planet we know today. Bombarded by asteroids and comets, racked by volcanic eruptions, and shrouded in a toxic atmosphere, it was a hellish and unforgiving environment. Yet, amidst this chaos, the seeds of life were being sown. The constant bombardment of comets and asteroids delivered water and organic molecules to the young Earth, providing the essential ingredients for life. Volcanic outgassing released gases from the Earth's interior, forming a primitive atmosphere composed primarily of nitrogen, carbon dioxide, and water vapor. As the Earth cooled, water vapor in the atmosphere condensed, forming vast oceans that covered much of the planet's surface. These primordial oceans, teeming with dissolved minerals and organic molecules, would become the crucible in which life first emerged. The early Earth's atmosphere lacked a protective ozone layer, exposing the surface to harsh ultraviolet radiation from the Sun. This radiation, while harmful to life as we know it, may have played a crucial role in the origin of life, providing the energy needed for the first organic molecules to form. Chapter 5: The Spark of Life. Theories on the Origin of Life. The question of how life arose from non-living matter is one of the most profound and enduring mysteries in science. While we don't have a definitive answer, scientists have made remarkable progress in understanding the chemical and physical processes that may have led to the emergence of life. One prominent theory is the RNA world hypothesis, which posits that RNA, not DNA, was the primary carrier of genetic information in early life. RNA, a simpler molecule than DNA, can both store genetic information and catalyze chemical reactions, suggesting it may have played a central role in the origin of life. Another theory focuses on hydrothermal vents, fissures in the ocean floor that spew out hot, mineral-rich water. These vents, teeming with chemical energy and raw materials, may have provided the ideal environment for the first life forms to emerge. Regardless of how it happened, the emergence of life on Earth was a watershed moment in cosmic history. From simple single-celled organisms, life diversified and evolved over billions of years, eventually giving rise to the incredible diversity of life we see today.
Thanks for joining us on this cosmic adventure. We've journeyed from the universe's fiery birth to the emergence of life on our pale blue dot, a testament to the awe-inspiring power of the cosmos and the intricate dance of matter and energy that makes life possible. But our exploration of the universe is far from over. There are countless mysteries yet to be unraveled, from the nature of dark matter and dark energy to the search for life beyond Earth. Don't forget to like, subscribe, and hit the bell icon for more fascinating insights into our universe. Keep looking up and never stop questioning the wonders of the cosmos.